So our last module for Chapter 5 is on theories of aging, and we're going to talk about two major theories, the program theory and the damage theory. So first, let's go ahead and start with the program theory of aging. And what this really emphasizes is the systematic genetic control of the aging process. And what this is based on is the idea of a maximum lifespan. So every species has a maximum lifespan. In other words, how long its longest living individual maintains. And so different species have different lengths of times. You've got the fruit fly that lives, a matter of a day or two. And you have something like the redwoods that live centuries, or, some of the turtles live well over 200-300 years. And we are certainly not that long lived, but we're not fruit flies either. But what it is based on is something called the Hayflick limit. And the Hayflick limit is that cells in humans double only about 50 times, plus or minus 10. And that plus or minus 10 is a big deal because it means how much your cells can get replenished. And of course, when that runs out, then you're left with what you have. And so that gradually will begin to decline. And that's why we have aging. So the issue is trying to have some influence on what we call telomeres. And so you see here in the illustration on your right, these are the telomeres. They're the little things at the end. So the best way I can relay on this in way of my thinking is if we take a bunch of beads and we tie a knot at the bottom of a string and put all the beads on there so it's all nice and long. And then we take some scissors, and every once in a while, we're splitting a cell, we snip a little bit off that knot at the bottom. Eventually, you're going to get to the point where the knot will not hold anymore. All the beads come rushing out. That cell is gone. So that's what we mean by a shortening of the telomeres. And it's referred to, the telomeres are kind of like a cellular aging clock. And that the shortenings is kind of like the timer off the chromosomal ends. And so the research efforts have been, how do we stop this from happening where the telomeres don't shorten every time we divide? And then in theory, if those don't divide, then we can live a relatively unlimited life span. So obviously, since we haven't conquered death yet, they have not succeeded. But they do talk about how there are things that we do that would predict those telomeres to be more resilient than not, usually in our genetic material, which is why if you look back and you study your family tree, see when people die, if you got people routinely making it into their 90s over a 200 to 300 year span, you're probably got pretty good genetics going for you, and you, in all likelihood, will live that long, barring any accidents or injuries. If, on the other hand, your ancestral tree is littered with people who die in their 40s and 50s, you're probably on the shorter end of those telomeres. So the individual genetic makeup really plays a big role in regards to this program theory. And I have a feeling you like the program theory if you happen to have long-lived relatives, and if you don't, maybe you don't like it as much. So that's one approach to why we age. And some of the evidence is pretty convincing, because humans, despite all of our advances from all around the world, the billions of people that live, we rarely get anybody much more beyond 120 years. And so there are a fair number of aging researchers who think that's probably our limit. Our maximum lifespan is around 120. But, science being what it is, who knows? We may figure out a way to greatly expand that at some time during either my or your lifetimes. The next of the theories we're going to talk about is the damage theory or error theory. And this emphasizes a lot more haphazard kind of process that says that there are errors in cells, and that those errors accumulate. And after they reach a certain tipping point, an organ system begins to deteriorate, and ultimately, all of this accumulated damage results in aging and eventually death. And the main culprit to this damage is something called a free radical. And the free radical is a toxic byproduct of our normal metabolic processes. damages cells. So when we are breaking down food, we are ripping apart various parts of structures, various chemicals and stuff, and occasionally a electron will go zooming off from that molecule, and that it'll start just ping-ponging around, making damage with anything that hits. And so what we need to prevent those free radicals from ping-ponging around as much is something called an antioxidant. And if you've watched various vitamin commercials and stuff, it'll say with antioxidants. And you probably are wondering, like, well, what the heck does that do? What an antioxidant does is it goes ahead and it absorbs some of those free radicals so that they don't keep ping-ponging quite around as long. And you can see the antioxidant there. What it does is it goes ahead and gives an electron to that free radical to stabilize it so that it's no longer creating that level of damage. They think things like vitamins A and E are antioxidants, and that they could increase our longevity if you have enough by inhibiting these free radicals. Now, I'm not talking about decades, though, maybe buy yourself a few days here and there kind of thing. And then another support for it was some intriguing research about caloric restriction. This was the idea that you feed people or to the ultimate closeness of starvation, but not starvation. And the idea is if you're not taking in food, then you have a lot less free radicals going around, and therefore you have less damage. And while interesting theory, they did try to put it to the test. And what they did is they gave rats a very controlled diet. And the ones that were on the caloric restriction retained their youthful look for a very long period of time, whereas a typical rat diet aged them quite significantly. And so there have been people who have tried to apply this to humans. Unfortunately, or fortunately, the research is not very encouraging at increasing your lifespan. Frankly, if you see the people who've tried to stay to this diet, I mean, they talk about them eating apples, but only the skin of the apple, which is the nutrition part, but frankly, not very tasty. I don't know. I like food a little too much to go through life, even if I think I'm going to buy myself a couple extra years. It doesn't strike me as a whole lot of joy in that sort of thing. So the good news, I guess, for those of us who like to eat is that it doesn't necessarily, those calorie restrictors really improve your overall lifespan. It certainly doesn't improve your quality of life. It's making me hungry right now. So neither of these theories by themselves explain aging totally. So what we see that it's probably an interaction of these two factors and probably some other ones that we haven't fully understood yet. But ultimately, all of those are causing our bodies to age and can contribute to the declines that we commonly see. And then ultimately, death can result, which we'll be talking about in our very last chapter in this textbook. So that's going to be chapter 5, the 5 modules there. We reviewed a lot of the physical growth kind of aspects, and we will be tackling chapter 6 next. So stay tuned for that one.